Online gaming is extremely popular these days. There are countless popular online games available today across different platforms, both free and paid. But did you know online gaming has actually existed as early as the 1970s? Multi-user dungeons, or MUDs, had their first iteration created in 1978. Now, an MUD is essentially a virtual world that provides the ability to play some sort of text-based game that combines elements of role-playing, combat, and fiction genres. But a while after online gaming came to life, anti-cheat systems also joined in. You've got early examples like Punkbuster and Valve Anti-Cheat, which released in 2000 and 2002 respectively. In this video, we're going to explore the concept of anti-cheat and its origins. We're also going to talk about anti-cheat software functionalities, how anti-cheats were in their earlier days, how they evolved, and the role of artificial intelligence in the anti-cheat space. Okay, so first of all, what's an anti-cheat system? It's basically software that is implemented in online games to prevent cheaters from cheating and gaining an unfair advantage. We've already mentioned a couple of them in Punkbuster and Valve Anti-Cheat, but other major anti-cheat systems include BattleEye and NProtect GameGuard. Anti-cheat systems became necessary when online gaming saw a significant rise in the number of cheaters and instances of cheating. This was problematic not only because cheating creates an unfair advantage for cheaters, but also because many cheats work by modifying memory or game code, which may actually constitute copyright infringement. Interestingly enough, there have been lawsuits, the foundation for which was copyright claims of this nature. But the most important reason that anti-cheat systems are around today is the gaming experience. This is for the most part financially motivated. Think about it this way. If you paid money to buy a popular game and it turns out that game is full of cheaters, chances are you won't keep playing, and you'll probably also tell your family and friends not to waste their money on that game. The same logic applies if you have the option of buying in-game currencies or benefits or anything of the kind that can be purchased with real money after you get the actual game. You'll most likely be discouraged to buy such things if you were considering it at some point. What all of this means is that you'll either refrain from making further investments into that game or not make any investments to begin with. This would deal a pretty big financial blow to game developers, which goes to show just how crucial anti-cheat systems have become. Alright, so now we know what anti-cheat software is and what brought it to life. But how does it actually work? Well, we mentioned earlier that cheaters do their thing by modifying memory or game code, and because they do that, these become the main point of interest for anti-cheat software. Anti-cheat software scans these areas and looks for any anomalies. What that means is anti-cheat looks through those areas and tries to find anything that is not right, or in other words, something that goes against specific instructions. If any anomalies are found and are deemed to be the product of cheating, that will trigger a response from the anti-cheat software that will have an effect on the cheater's game. Now, different measures are taken against cheaters, and these are usually determined by the game developer. There is a more aggressive approach taken by anti-cheat software, but we'll talk about that a little later. A very common form of punishment for cheating is bans. Bans can be enforced for a period of time, but they can also be permanent, in which case a player wouldn't be able to play the game under whatever account they were using anymore. Of course, bans can be partial, meaning they may block only certain game modes, but they can also be super harsh and block the player from playing the game entirely, unless of course they create a new account, in which case they'd have to start from scratch. Another slightly less common form of punishment for cheating is through in-game kicks. This is a more lenient form of punishment and usually involves kicking or banning a cheater from a game lobby rather than banning them from the actual game. This is basically a double-edged sword because on the one hand you're giving the cheater a chance to review their actions without significant damage to their gaming experience, which is good. At the same time though, you're also giving them the opportunity to just bounce right back in and continue cheating, which is not good. Aside from anti-cheat software being a welcome addition, what were anti-cheat systems like in their earlier days? There was definitely a mix of positives and negatives. Let's start with some positive talk. In 2001, Valve stopped using Punkbuster in their games in favor of their own in-house Valve Anti-Cheat, or VAC. Valve kept developing VAC, and they made a breakthrough in effectiveness in 2006, which they documented by stating that they caught over 10,000 cheating attempts in 1 week alone. This brings us to the negative part. 4 years later, 12,000 Call of Duty Modern Warfare 2 players were wrongfully banned when Steam updated a DLL file, which is basically a file containing code and data that can be used by programs to perform certain operations. This happened after the DLL file had been loaded into the memory by the game. This is referred to as a false positive. VAC was also criticized for not being able to detect LMAO box for years. LMAO Box is a popular cheat program for Team Fortress 2, and VAC was eventually able to detect it halfway through 2016. But away from VAC, let's talk a bit about Punkbuster, which also saw its fair share of false positives. In the week between the end of October and the start of November 2013, Punkbuster was falsely banning Battlefield 4 players based on an error that was not even triggered by cheat software. This issue was resolved by Even Balance, the developer of Punkbuster, on November 8th of that same year. So as you can see, the state of the anti-cheat space in the earlier days was very interesting. On one hand, cheaters were finally getting stopped, but on the other hand, anti-cheat software had clear limitations. This particular aspect can be divided into two main elements. The first one being hackers and cheat developers maintaining a dominant edge over anti-cheat software developers, and the latter often finding themselves having to catch up. The second element comes from the occasional incompetence of anti-cheat software developers that leaves loopholes for exploits, like the attacks on Punkbuster in 2008, but also flaws that don't necessarily allow for cheating, but instead harm the player's experience with the game they're playing, such as false positives. Basically, anti-cheat software developers sometimes end up shooting themselves in the foot. However, as the years went by, the balance started to become more even, with online games becoming more difficult to cheat in thanks to more advanced cheat detection. The increased difficulty for hackers to develop effective and undetected cheating tools has resulted in less cheats being released compared to before, but there's also another reason for this decline. Take Supercell for example, the company responsible for games like Clash of Clans. If at some point in its earlier years you played this game, cheating tools like Xmod and iMod might ring a bell. These specific tools gave Supercell a headache for years until they eventually patched them. Clash of Clans became so difficult to cheat in to the point where Xmod and iMod developers just gave up. Okay, now earlier in this video I said that there is a more aggressive approach to detecting cheats. That approach involves anti-cheat software targeting the kernel, hence the name kernel level anti-cheat. But what's a kernel? Simply put, a kernel is the core part of an operating system. It manages resources like the computer's memory and the CPU and allows software to communicate with hardware. So it basically acts as a bridge between software applications and hardware. Now, obviously the existence of kernel level anti-cheat is self-explanatory. More advanced means of cheating involve operating at the kernel level. We've seen this in a lot of games like Fortnite, Counter-Strike 2, Valorant and Genshin Impact. Similar to Valve's VAC, Fortnite and Genshin Impact use in-house anti-cheat solutions, which are Easy Anti-Cheat and MHY-Prot2 respectively. Now, in the case of Fortnite, you can argue that technically Easy Anti-Cheat isn't an in-house solution, since Easy Anti-Cheat was separate from Epic Games until Epic Games acquired it in 2018. But because Easy Anti-Cheat now falls under Epic Games, we can count it as an in-house solution. But what's more interesting is what happened recently with Genshin Impact. There is a popular mod menu for the PC version of this game called Minty that was recently renamed to Sheikah. I hope I'm pronouncing that correctly. Now, what was interesting is that this particular cheating tool was undetected all the way up to around August-September of 2024, when Hoyoverse seemingly updated their in-house MHY-Prot2. Now, obviously this wasn't officially communicated, as is the case of many anti-cheat developers, because you generally don't want to let your enemy in on your game plan. But Genshin Impact started successfully banning Sheikah users. Now, what's interesting about this is that those banned players have something in common, which is that they were all connected to the game's Asian server. So for context, Genshin Impact has 4 main servers: Asia, Europe, America, and a server for Taiwan, Hong Kong, and Macau. Interestingly enough, all banned reports were from players on the Asian server, with very few reports, if any, from players on the European and American servers. What could be the reason for this? It seems like the update to MHY-Prot2 only covers the Asian server, which raises questions as to why the other servers aren't covered by that update. Now, this could be a multi-stage release where they release it for one server and then maybe later they release it for the other servers. But why not do it for all servers at once? This raises some concerns that perhaps something shady is going on, but of course this is mere speculation. What is not speculation though is that kernel level anti-cheat has been the subject of much criticism because of its invasive nature. Because the anti-cheat software is granted such high access privileges, user privacy becomes an issue. Genshin Impact was no exception, and just over 4 years ago, Hoyoverse posted a statement in which they acknowledged that MHY-Prot2 would continue to run in the background after the game is closed or even uninstalled. They said that they had resolved the issue and that MHY-Prot2 would stop running as soon as the player closes their game. Artificial intelligence technology has reached a point where it's becoming increasingly useful in the anti-cheat space. Now you might think about this and say, oh, this is good. Well, it is good, but unfortunately it's not as good as you might think. While anti-cheat software developers are starting to incorporate AI into their anti-cheat solutions, hackers and cheat developers are doing the same with their cheats. FPS games seem to be affected by this the most. So what challenge does this create? Well, first of all, it seems like AI is helping in addressing cheating at the kernel level. The problem that's occurring is that cheaters are finding ways to overcome even these improvements to anti-cheat software. This is being done in ways like having AI improve existing cheats by teaching those cheats to accurately impersonate legitimate player behavior to a point where cheating and legitimate behavior become indistinguishable to the anti-cheat. This is made worse when coupled with the use of hardware to emphasize the undetected nature of such cheats, particularly external hardware. From a PC perspective, since this is where it's most achievable, a functional environment of this kind would involve a main PC where the game would be running, but no cheats being run directly from that PC. Instead, a second PC containing those AI-based cheats would be tasked with interpreting visual game data from the main PC while the game is running. After this, the second PC transmits a signal to the main PC in the form of some kind of action relevant to the game in question. In the case of FPS games like CS2, that would likely be optimal keyboard and mouse input to ensure maximum movement and shooting accuracy, all while maintaining the disguise of legitimate player behavior. Now, there may be a need for an intermediary piece of hardware that can provide the means for communication between those two PCs, like an Arduino, for example. Such circumstances may force game developers to also rely on human methods of detecting and addressing cheating. You've got Overwatch in CS2, for example, which involves humans going through game footage involving suspected cheaters and making a decision based on what they see. A person who has high attention to detail and knows what they're looking for will likely be able to correctly identify cheating instances most of the time. But with how advanced those AI cheats are getting, even talented humans are susceptible to making a wrong call, like considering legitimate player behavior as cheating, and vice versa. Thank you so much for watching. I really hope you've enjoyed this video. If you have, please like, share and subscribe. And feel free to let me know in the comments if there is anything tech that you're interested in and want me to make a video about. In the next video, we're going to discuss the future of mobile connectivity. I think it's going to be very interesting, so make sure to tune in for that. Also, please consider supporting me by donating to my channel through buymeacoffee.com. I would really appreciate any support as I continue to bring fun and interesting content like this, only if you can, of course. Link is down below. This was the Wizard of Tech, and I'll see you in the next video. Take care.